Hello friends, welcome to this video. So here we are going to learn about graphical representation of motion. Okay, so how do we represent motion graphically? So here we are discussing a distance time graph. Okay, distance time graph. So in distance time graph, what is done basically? Distance is time is taken along the x-axis. Okay, x-axis is this horizontal axis, and a distance is taken along the y-axis. Okay, y-axis is this vertical axis. Okay, so one example is given here. An object, suppose at time 0 second, so it is at rest. Okay, it has not started moving. So after 5 seconds, it has moved 10 meters. After 10 seconds, it has moved 20 meters. After 15 seconds, 30 meters. After 20 seconds, 40 meters. And after 25 seconds, 50 meters. Okay. Suppose you have been given some data like this. Okay. At certain time intervals, how much distance the object has moved. Now, if you were asked to plot this data graphically, then what would we get? Okay, graphically we would get this. Okay, time is plotted along the x-axis and distance is plotted along the y-axis. So all these points we get to see. Okay, so first point, second point. Okay, so but the 0 time, it's 0 meters here. After 5 seconds, okay, this is 5 seconds. This corresponds to 10 meters here. After 10 seconds corresponds to 20 seconds, so on. Okay, so after see if so we can connect all these points. Okay, all these points that you see, we can connect these points by a straight line. Okay, so what does that mean? Okay, so in the given example, the plot is a straight line. This signifies uniform motion. Okay, so for this example, if you put distance against time, so the graph, which the distance time graph which you would get, it will be a straight line. Straight line means the motion is uniform. Okay, uniform motion is again if an object covers equal distance at equal intervals of time, then the motion of the object is uniform motion. So here you see 5 seconds, the object has covered 10 meters. Here also 5 seconds, here 5 to 10, 5 seconds, 10 meters, 10 to 15, 10 meters, okay, 15 to 20, 10 meters. So this way, at each 5-second interval, the object has covered how much distance? 10 meters distance, okay. So this is known, this type of motion is uniform motion, and for uniform motion, we get a straight line. Such a graph is used to calculate the speed of an object, okay. So what do you obtain from a distance time plot? Distance time plot is used to calculate the speed of an object. Take any two values of time and distance, okay. So here this one. So speed, how can you calculate the speed? How can you calculate the speed of an object from this type of table or this type of plot? Okay. So here two values are taken. So how much distance the object has moved after 5 seconds, that is 10 meters, and how much after 20 seconds, that is 40 meters. So what is the displacement of the object in this case? The displacement of the object would be 40 minus 10. Okay, 40 minus 10. So earlier it was it covered 10 meters and now it covered 40 meters. So 40 minus 10, that would be the distance the object has covered. And how much time the object has taken to move this 40 meters from 10 meters? It 5 seconds and then 20 seconds. Okay, so 20 minus 5, that is the time difference, and 40 minus 10, that is the distance difference. So 40 minus 10 is 30, 20 minus 5 is 15. So 30 by 15, the speed of the object that we can calculate from the given data is 2 meters per second. Okay, so this is how you can calculate the value of speed from a velocity, sorry, from a distance time plot. So another way of calculating velocity from this distance time plot is just by taking slope of this graph, slope from this graph. So let me consider 2 points, maybe this point and this point. Okay, so can I connect these 2 points by hand? Okay, so it will not be a very good looking straight lines. So yeah, suppose this we have drawn slope. Okay, so slope. What is the slope? Slope is the value. The slope is the change in value of x-axis divided by. Sorry, the change in value along the y-axis. Sorry. Uh, Eraser. Okay, I have erased it. Okay, how can we calculate the slope? The change in value of y-axis divided by the change in value of x-axis. Okay, so y-axis changes. So how much is this? This is 10. How much is this? This is 40 again. 40 minus 10 divided by the change in x-axis value, that is 20 here. Okay, and here, although the 5 and 20 points are not given, but we can easily find them out from the graph. Okay, so 30 by 15, that is again 2 meters per second. Okay, so by calculating the slope also, and if you calculate the slope from these 2 points also, we'll again get that the velocity is 2 meters per second. So let us check. This is 30 divided by 20, so it's 10, and the time difference is 5 seconds. So 10 by 5 will be again 2 meters per second. Okay, therefore the velocity can be calculated from distance time plot as given here, and that comes out to be equal in each case for a uniform motion. Okay, for an accelerated motion, so how would you plot an accelerated motion? Accelerated motion is the speed of the object is always increasing with time. So here take this example, at 0 second distance covered by the object is 0. After 5 seconds, it has covered 6 meters. After 10 seconds, 17 meters, 15, 34, 20, 58, 25, 91 meters. Okay, so all these points have been, you can see the plots. Okay, all these points. So this is not a straight line. Okay, so if you put all these points on a graph, and you will see that it is a curved line. It is not a straight line. Okay, therefore this is a non-uniform motion. Okay, non-uniform type of motion, and non-uniform, and the velocity is increasing. Okay, the velocity, so distance, it is increasing. So distance increasing with time is velocity is increasing. So velocity is increasing with time, that means such motions are accelerated. Okay, such motions are accelerated, and in accelerated motion, distance and time plot is not a straight line. Okay, in accelerated motion, distance and time plot will be curved, not a straight line but curved. Okay, the graph is increasing on higher side, so the motion is accelerated. Okay, so distance time plot will be is increasing on the higher side. Higher side means higher values of time, so means its velocity is increasing with time. So this type of motion is accelerated motion. Okay, so again, velocity time graph can be there similarly. Okay, we have just discussed distance time graph. So what is done in velocity time graph? So velocity is plotted along the y-axis, and time is plotted along the x-axis. Okay, so here some values are given: 0, 0, 10, 5. Okay, that means after 10 seconds, the object has a velocity of 5 meters per second. So this way, for each time values, we have got velocity values. So plot them in graph, and you will see that all of them are actually straight lines. Okay. Okay, so all the points, if you connect them, you will get a straight line. Okay, so this is an uniformly accelerated motion. Okay, the velocity changes. Okay, why uniformly accelerated motion? Because the velocity changes equal at equal interval of time. Okay, so 10 seconds 5 meter per second change in velocity, another 10 second 5 meter per second change in velocity, another 10 second 5 meter per second change in velocity. Okay, so at equal time intervals, the velocity of the velocity of the object is changing at equal rate. Okay, so such motions where velocity is changing equally at equal time intervals are known as uniformly accelerated motion. Okay, and for uniformly accelerated motion, we will get a straight line between velocity and time. Okay, velocity time plot for such a motion is straight as shown in the plot here. Okay, so I hope you have understood all the concepts. So how we can graphically represent distance, time, and velocity time. What will be the nature of a plot for uniform velocity, and what will be the nature of the plot for uniform acceleration. So what information we get from distance time graph? So from distance time graph, we can calculate the speed, and from a velocity time graph, we can calculate the acceleration. Okay, so again, one thing I missed here, acceleration calculation. So how can we calculate the acceleration from this given graph? So consider any two values, maybe 0 and 20. Okay, 0 and 20, and their corresponding velocities. So what is the change in velocity? Velocity change is 10 minus 0. What is the time change? Time change is 20 minus 0. So acceleration unit is always meter per second square. So 10 by 20 meter per second square, which gives us half, or 0.5 meter per second square is the acceleration. Okay, so that can also be calculated graphically like before. If we take these 2 points, this point and this point, we draw a slope. So what is the change along y-axis is 10. What is the change along x-axis? That is 20. 40 minus 20 gives us 20. So meter per second square. Therefore, it is 0.5 meter per second square. Okay, so that is how you can calculate the acceleration from velocity time plot. Okay, I hope you have understood the distance time and velocity time plots. If you have liked the video, please like it and share it, subscribe to the channel, and thank you very much for watching, and we'll see you in the next video. Thank you.